Now start statistics and probability. Statistics and probability are essential because these disciples form the basic foundation of all machine learning algorithms, deep learning, artificial intelligence, and data science. In fact, mathematics and probability is behind everything around us. Shapes, patterns and colors to the count of petals in a flower. Mathematics is embedded each and every aspect of our lives. With this in mind, I welcome you all to today's session. I'm going to go ahead and discuss the agenda for today with you all. Gonna begin the session by understanding what is data. After that we'll move on and look at the different categories of data like quantitative and qualitative data. Then we will discuss what exactly statistics is, basic terminologies and statistics, and a couple of sampling techniques. What is data? So this is a quite simple question. If I ask any of you what is data, you'll see that it's a set of numbers or some sort of documents that I've stored in my computer. Data is actually everything. Alright, look around you, there is data everywhere. Each click on your phone generates more data than you know. Generated data provides insights for analysis and helps us make better business. This was why data is so important. To give you a formal definition, data refers to facts and statistics collected together for reference or analysis. This is the definition of data in terms of statistics and probability. So as we know, data can be collected, it can be measured and analyzed. It can be visualized by using statistical models and graphs. Now data is divided into two major subcategories. Alright, so first, we have qualitative data and quantitative data. These are the two different types of data. Under qualitative data we have nominal and ordinal data. And under quantitative data, we have discrete and continuous data. Now let's focus on qualitative data. Now this type of data deals with characteristics and descriptors that can't be easily measured, but can be observed subjectively. Qualitative data is further divided into nominal and ordinal data. Nominal data is any sort of data that doesn't have any order or ranking. Okay, example of nominal data is gender. Now there is no ranking in gender. There's only male, female or other. There is number 1234 or any sort of ordering in gender. Race is another example of nominal data. Ordinal data is basically an ordered series of information. Okay, let's went to a restaurant. Okay, your information is stored in the form of customer ID, right? So basically you are represented with a customer ID. You would have rated their service as either good or average. Alright, that's how ordinal data is. Similarly, they'll have a record of other customers who visit the restaurant along with their ratings. Alright. So any data which has some sort of sequence or some sort of order to it is known as ordinal data. Alright, so guys, this is pretty simple to understand. Now let's move on and get quantitative data. So quantitative data basically deals with numbers and things. Okay. You can understand that by the word quantitative itself. Quantitative is basically quantity, right? So deals with numbers, deals with anything that you can measure objectively, right? There are two types of quantitative data. There is discrete and continuous data. 3 data is too known as that can hold a number of possible values. Now the numbers in a class is a finite number. Alright, you can't have an finite number of students in a class. Let's say in your 5th day 100 in your class, right? They weren't in finite number, the definite sort of students, you know. Okay, that's data. Next we have conduit data. Now this type of data can hold an finite number of possible values. So when you say weight of a person is an example of continuous data. What I mean to say is my weight can be 50 kilograms, or it can be 50 kgs, it can be 50.001 kilograms, or 50.0001 is 50.23 and so on, right? There are an infinite number of possible values, right? So this is what I mean by continuous data. Alright, the difference between discrete and continuous data, and also to mention a few other things over here. Now, there are a couple of variables as well. Alright, we have a discrete variable, and we have a continuous variable. Discrete variables, also known as a categorical variable, and it can hold value or different. Please say that a variable called message. There are two types of values that this variable can hold. See the message can spam or non-spam message. Okay, that's when you call a variable as discrete or categorical variable, alright, because it can hold values that represent different categories of data. Now, continuous variables, basically, that can or infinite values. So we have a person, that has a condition, or let's say, that we'll call weight and can store a number of possible values. That's why we will call it a continuous variable. So guys, basically build a thing that value, right? So associate any sort of data with a variable, and it will become either discrete variable or continuous variable that is also dependent and independent type of variables. Now, we won't discuss all of that in depth because that's pretty understandable. I'm sure all of you know what is independent variable and dependent variable. Dependent is the variable who depend on any other independent variable. So guys, that I expect all of you to have alright. So now let's move on and look at our next topic, which is what is statistics. I'll make a formal version of X. That is, the X is an area of applied data which is also sound with a data collection, analysis, interpretation, and presentation. Now usually when I speak about statistics, people mean statistic is all about analysis. But statistics has the parts to it that has data collection is also a part of that sticks, data interpretation. Statistics is an area of applied mathematics which is concerned with data collection, analysis, interpretation, intuition. Now usually when I speak about statistics, people think statistics is but statistics has other parts to it. It has data collection is also part of statistics. Data interpretation, presentation, visualization, all of this comes into statistics, or that you're going to use statistical methods to visualize data, to collect data, to interpret data. Right. So the area of mathematics deals with understanding how data can be used to solve complex problems. Okay. I'll give you a couple of examples that can be solved by using statistics. That your company has created a new drug that may cure cancer. How would you conduct a test to confirm the drug's effectiveness? Even though this sounds like a biology problem, this can be solved with statistics. You will have to create a test which can cover the effectiveness of the drug, or this is a common problem that can be solved using statistics. This is another problem that comes under statistics. Let's look at another example. The latest sales data has just come in and your boss wants you to prepare a report for management on places where the company could improve its business. What should you look for and what should you not look for? Now this problem involves a lot of data analysis. You have to look at the different variables that are causing your business to go down, or you have to look at a few variables that are increasing the performance of your models and your business. Alright, so this involves a lot of data analysis. And the basic idea behind data analysis is to use statistical techniques in order to figure out the relationship between different variables or different components in your business. Okay, so now let's move on and look at our next topic. Just basic terminologies in statistics. Before you dive deep into statistics, it is important that you understand the basic terminologies used in statistics. The two most important terminologies in statistics are population and sample. Throughout the statistics course, or throughout any problem that you're trying to solve with statistics, you will come across these two words, which is population and sample. A population is a collection or a set of individuals or objects or events whose properties are to be analyzed. Okay? So basically, you can refer to population as a subject that you're trying to analyze. A sample is, just like the word suggests, it's a subset of the population. So you have to make sure that you choose the sample in such a way that it represents the entire population, right? It shouldn't focus at one part of the population. Instead, it should represent the entire population. That's how your sample should be chosen. So a well-chosen sample will contain most of the information about a particular population parameter. Now you must be wondering, how can one choose a sample that best represents the entire population? Now sampling is a statistical method that deals with the selection of individual observations within a population serving in order to infer statistical knowledge about a population, right? If you want to understand the different statistics of a population, like the mean, the median, the mode, or the standard deviation or the variance of a population, then you're going to perform sampling, right? Because it's not reasonable for you to study a large population and find out the mean, median, and everything else. Why is sampling performed? You might ask, what is the point of sampling? We can just study the entire population. Now guys, think of a scenario wherein you're asked to perform a survey about the eating habits of teenagers in the US. So at present, there are over 42 million teens in the US. This number is growing as we are speaking right now. Correct. Is it possible? So will each of these 42 million individuals about their health, is it possible? Well, it might be possible, but this will take a while to do. Obviously, it's not reasonable to go around knocking each door and asking for what does your teenage son eat and all of that, right? This is not very reasonable. It's my sampling is used. It's a method wherein a sample of the population is studied. All infants for the entire population. So it's basically a shortcut to studying the entire population. Instead of taking the entire population, putting out all the solutions, you're just going to take a part of the population that represents the entire population. You're going to perform all statistical analysis, your inferential statistics on that small sample, right? And that sample basically represents the entire population. Alright. So I'm sure we've made this clear to you all what is sample and what is population.